Okay? Now, whenever you are answering a questions involving two circles, okay? If you are asked to prove whether the circles intersect or they touch, if they are intersecting or rather touching, are they touching internally or externally? You need to be aware of the following. Since you'll be having two circles, right? Most of the time, one of the two will be a very large circle. Okay? Then you also have a smaller circle. So you need to know the radii of both circles. Okay? Now, those two radii, if you are not given, it means you might be given the equations of those circles. So you have to complete the square if it's not written in standard form. Then you can determine your what? Your two radii. Then also, you may need to determine the distance between the two centers of those circles. And that distance, you can represent it by a small letter d. So the small letter d is the distance between the two centers of the circles, right? Like this diagram. So you have got the radius of the large circle, the radius of the smaller circle. The sum of the two radii, that will be equivalent to d. Now, in a case like this, okay, whereby the sum of the two radii is equivalent to the distance between the two centers, you can say, therefore, the circles touch externally. Okay? The circles touch externally, which means they are only coming into contact at one point. It's more like the case of a circle and a tangent. Okay, so this is the first case. Okay, now a question like this, in most cases, it will come more like a proof. Okay, they'll give you the equation of the two circles, then they say prove that the two circles touch externally. So remember, you need to find the length of the two radii, determine the distance between the two centers. And usually, to find this d, you just use the distance formula, which means you know the coordinates at the center of the big circle, you know the coordinates at the center of the smaller circle, use the distance formula, calculate the distance between the two centers, determine the radii of each circle, add them, and see if they are going to be equivalent to the distance between their centers. If the distances between the, or rather, if the distance between their centers is equivalent to the sum of their radii, then the two circles, you can conclude that therefore they touch externally. So this is the first case. Sometimes the circles can also touch internally, which means one of the two circles, the smaller one, will be inside the bigger one. In such a case, the same thing, determine the radii of the two individual circles. Now, where do you get the radii? From the equations of the circles. Then, you need to calculate the distance between their centers, right? Now, in a case like this, if the distance between their centers is less than the difference between the radius of the large circle and the radius of the smaller circle, you can conclude that therefore the circles touch internally, right? So this involves some common sense. Okay, so this is the internal case. Okay. Generally, one of the two of these two can come. Okay, it hasn't come in recent years. Okay, as your June exam, I didn't put a question where I tested this, but you might see it in your trial exam, you might see it in your final examination. Any questions so far?
So the say we have to prove it. So what would they give you two circles and say?
We'll give you two circles and their equations.
Okay.
Right? So from there, from the equations of the two circles, we are supposed to determine their centers, also determine their radii. Okay? Using the coordinates of their centers, calculate the distance between their centers. Then check if the sum of the two radii is equivalent to the distance between their centers. If they are equal, then the two circles touch externally. If the distance between their centers is less than the difference between the two radii, then the circles touch internally. That's all. Okay, don't worry, I'm going to give you a question to do. I'll give you a question, but this is the general concept. You can't see which part. Okay, I'm going to send you a booklet on questions on analytical geometry. Are you okay? Let me scroll down. Okay, can you allow me to carry on? Was our lesson, listen, by the end of this lesson, this we must have done an example on this one example, but I'll give you as a class exercise to do. Okay, can I move on, please? All right, on the other side, I hope you can see that. All right, now it's very possible, it's very much possible that the circles may not touch. Okay, what do you think is going to happen if the two circles don't touch? What do you think will happen to the value of D? The value of D will increase. So if the two circles don't touch, D will be greater than the sum of the two radii. Okay? So let's move on to the next page. Now, when okay, so intersecting. Right? Now, if the two circles don't intersect, what it means is that the distance between their centers will be greater than the sum of their two radii. Now that comes from common sense as well. So you have a scenario like this, okay, where the distance between their two centers D will be greater than the sum of their two radii, and the diagram will look like this. Okay. So yes, it's actually the last part of analytical geometry. Tomorrow I'm going to start a new topic, functions and inverses. Okay, the problem is that it's an issue of time. Okay, so what's your suggestion? On what? Okay, let me tell you. Alright. Can I have your attention? Can I have your attention? Alright. Now, can I have your attention? Now, it is possible that you can have one smaller circle inside the larger one, but they don't touch. Okay? Now, in that case, it means the two centers will be too close to each other. Okay? Which means the value of D, that is the distance between the two centers, will be extremely small. Okay? So you can also have a case like that where the D is extremely small, okay, as compared to the difference between the two radii. Okay, I just want you to be aware that based on the ATP, we're only supposed to have 6 lessons on analytical geometry, grade of 6 lessons. So today is our 6th lesson. Okay, and listen, I cannot have a 7th lesson, 8th lesson, because we have got 2 more topics, including calculus, which is a very long topic that we have to cover before the June exam. Okay. What? Start the calculus. Why didn't you start with it? Because it's such a big section. You said you've done it before. No. That's not. Okay. Listen, it's better to start with functions because some of the knowledge from functions you require it in calculus. So we start with functions first. Okay. I think I'm done with this. All right. Okay. Okay. At the moment, I'm not 100% sure, but it should come with a uniform, I think. Okay. Can I have your attention? All right. In your math workbook, can you please just write class exercise? Class exercise. Right. You must do. You must show me your answers just now. Right. We only have about almost like 19 minutes before the lesson ends. So what I want you to do is do exercise 4, A3, A3 only, and also do C2. Okay, A3 and C2. A3 and C2. Okay, if you are done, you must come and show me your answers. Listen, can I have your attention? Please stop wasting time. You can go back to the notes and check, but this is very simple. Okay, don't complicate it. All right, so do A3 and C2. You do it. Can you do A3 and C2, please? Stop talking. Do A2, sorry, A3 and C2. Talking is not going to help.
Super, where do you get the information for the second step?
Which second step? No, the first question, can I have your attention? It says, determine whether each of the following points is inside, outside, or on the circumference of the circle. All right? Earlier, before the previous lesson ended, okay, Stella, if I'm talking, you're supposed to keep quiet. Okay? That's very basic. All right? Find the distance between the point and the center. Calculate your small d. Okay? Then use your common sense together with the radius of the circle to determine whether that point is inside the circle or not. That's all. It's not difficult at all. And then for C2, you just have to prove that the circles touch externally or internally. Or you also have to prove that they touch externally as well. Okay, that's C2 there. It's not difficult. Calculate your distance between the two centers, determine the two radii, and use those values to come up with a conclusion. That's all. I think around page 220. Can you stop talking, please? I need you to show me your answers before you go.
Yeah, sir. Like, can you do one of that? And then we know how it's supposed to be done. Yeah. And then we have examples of it. Hey! Oh, confused picture.
Okay, A1. Okay. Right. Let me just take the question to my e-beam quickly. I think you like to be spoon-fed. You like to be spoon-fed. Just admit it that you like to be spoon-fed. Okay, sorry. Wait. All right. Listen. Okay. I think you also need to do the last one where circles intersect at 2 points. But don't worry, we'll copy this down at the end. Let me just do one example on this. Well, some of you are starting to stress already. Okay. So let me do the first one. Can I have your attention? So we're going to do that one there. Now, the question, pay attention. The question says, determine whether each of the following points, okay, is inside, outside, or on the circumference of the circle. Now, we are given our equation of our circle, x minus 3 squared plus y plus 5 squared equal to 25. Obviously, our center is going to be at x equal to 3 and y equal to what? Y equal to 5. The radius is going to be 5 units.
Yes.
Are you following that?
Yes.
Right. Now, if we want to determine whether this point here is inside the circle or outside the circle or is on the circumference, we just have to calculate the distance between that point and the center of the circle. So the distance between the point and the center of the circle, we use the distance formula. Okay? So that will be x2 minus x1 squared plus y2 minus y1 squared. Are you following that?
Yes, sir.
Okay? Then you can decide which point you want to make your x1, y1, x2, y2. Well, let me choose the center as my x2. So this will be 3 minus 2 squared plus, okay, plus minus 5 minus 3 minus 5 minus 3 squared. Okay, if you simplify this, this will give you 5 squared and that will give you minus 2 squared. So you end up having the square root of 25 plus 4, okay, which gives you the square root of 29. Are you following that? All right, now, then we must compare now using common sense. Is square root of 29 greater than 5. Is square root of 29 greater than 5?
Yes.
Now, we're saying no.
Yes.
Yes, it is. So here, D is greater than R. What does that mean from common sense? The point would be what? Outside the circle. So we say D is greater than R, therefore the point is outside the circle. What if D was equal to the radius? Then the point would be what? The point would be on